All right, welcome. Thanks for joining us. I'm Ryan Holger. We have with us Dave Herman again today. All right, solve the audio problem. We're sitting next to each other, as you probably can tell, which makes the audio really weird. So if you're not aware, these are monthly invites that we're doing. Kind of a Q&A. We got kind of a general template of what we want to talk about, but then questions from you guys. You could type questions in the question box, and I'll read them out. Or you can be unmuted, and then you could ask your question verbally if you prefer to do that. So the first one we did was heat pumps, and then last month we did R54B, which we live streamed on YouTube also, so that's recorded there. And this month we're going to focus on refrigerant piping. So some piping basics, some brazing tips, and then we'll go through the long line application guide as well. So with that, I'm going to start off with the regular install manual. So hopefully you guys know where to find those. Let me share my screen so you can see it. Share screen. Boom. All right, so now you're seeing the same thing we're seeing. This one happens to be for a 17 SEER 2-stage, but the idea is basically the same. So in the installation manuals, obviously there's a bunch of tips. And one of the things that Dave wanted to start us off with today was selecting the sizing of the refrigerant piping that you're going to be doing. So you talk a little bit about that.
Yeah, when you get into the line sizing, guys, you always have, I won't say guys, I'll say people. I'm gonna cover everybody. As far as the line sizing goes, it's gonna be listed in all the installation guides, which very rarely people ever look at, but all that information is listed in there. Generally, the sizes on most of the units, you're gonna have the 3/8, 3/4, 7/8. You get into the larger units, you're gonna run into, or long runs, on a 4 ton, 5 ton. You may get into that 1.1 inch, but that's all gonna be listed. Standard line sizing is gonna be listed in the regular installation guide. So it's something that's not too complicated to find. For some reason, we get questions on it, more than you would think we would. But again, the information's fairly available, whether you find it online or the actual installation guide that comes with the units. As far as that goes, when they get anything behind that, we'll get into it a little bit more, but the long line guide that Carrier provides, there's a couple different versions of it. Looking through the newest version of it, it doesn't give all the information that the old one did as far as percentage of loss you get when you have different size lines that may not be ideal for the tonnage, the capacity of the unit you have. But the old version of that guide, which I didn't see it in the new version, it does have, gives you an idea how much of the percentage of loss with the unit. Say, if you have lines that are buried in a wall and, based on your distance, you should be going with the 7/8, 3/8, because our liquids are always going to be 3/8. But we, should be 3/8, 7/8 on our suction, but it's 3/4 and it's buried in walls and there's nothing you can do about it. So there will be some capacity loss on that unit, which the old version of the long line guide would give you all that information. So it's stuff that, in a lot of cases, it doesn't affect, too much, because you can't really just start upsizing based on that. But it'll give you an idea if you're borderline for some reason as far as the capacity that you do need.
So on the regular length, not the long length, but the one we have up on the screen, if I only had a 3/4 line on a 3-ton, I could use that, just knowing that I'm going to have a D rate.
Yeah, they'll actually give you the chart and it'll show how much loss you'll have, whether you'll have, depending on the amount of footage you go, you may have, a 2% loss, a 3% loss, a 5% loss, but it will list it in that original long line guide. So that's something that you could find on Partners or on probably on Google at this point,
Yep.
search it.
For those that aren't regulars, Partners means HVACpartners.com. So all the Carrier, Bryant, Heil, day and night type dealers have access to that.
You also have it access to these guides through the Carrier, Bryant, or the ICP service tech apps. So the stuff should be able to be located, relatively easily on there also.
Other than a capacity loss, is there anything else that would be problematic if I go with a smaller size line?
Generally, no. With the line sizing, some of the stuff we run into on the VNA units, especially the 5-stage that have 100-foot maximum line length, you're worried about moving oil if we go too far or get too big, depending on the capacity of the unit. So the concerns most of the time is an oil issue. So generally, no.
Oil, I mean, returning it back.
Returning it back, getting oil circulate through that
Because
system.
you have an inverter, you're ramping down, you're not moving as much. and
Yeah,
oil
you don't
gets
have the
stuck.
strength, especially on that 5-stage VNA. That can be a serious problem. Line sizing, lines too long beyond that, 100-foot maximum, and you just can't get oil circulated through the system well enough, which causes compressor issues and faults and failures. So again, specifically on units, if they do have maximum line length that should be used, you should adhere to that to avoid any possible problems.
Most of them are pretty long. So the 5-stage is 100 feet. I know the Reflex is 100 feet. Most other ones are like 250 feet.
Most of them go,
yes.
Yeah. Sometimes you might have to go into the long line guide, which, make some changes, liquid line solenoid. You may have to do something that way in order to go that longer distance. But it's rare when you have to generally go that far. I think most people find on residential installations, you generally aren't running stuff 250 feet, occasionally maybe, but, and if you could, always, it's always best to avoid that if possible. When you have those extreme line lengths, that's never ideal, but sometimes you just don't have a choice. Also, as far as lines go, they come down, there's always a question of burying lines, and that comes up a lot with dealers. They'll go to a job and the lines are buried across the backyard.
Buried meaning underground.
Underground.
Okay.
When I say buried. Yeah, so that can't be. You have a 3-foot maximum of as far as lines being allowed to be buried in the line set, and that's it. And you don't want any more than that. There have been situations where stuff is buried, whether we're talking, residentially or even commercially, you bury those lines and it causes all kinds of issues. Because obviously the environment changes, pressures, temperatures, and it affects the equipment. So it is not good to bury those lines at all. But again, 3-foot maximum as far as burying lines residentially when we're talking about the equipment. So do not bury lines.
Yeah, we get that question a lot. I didn't get that question. I don't do much piping stuff, and it's just a hard no. And I know there's a lot of existing ones that are out there, and it's kind of sort of working, but there's no scenario in which anybody at TC or Carrier ever says yes to that for you. So hence you don't have a warranty. This is the long line guide that Dave was talking about. They do update it periodically. I mean, it's been the same document for, I don't even know, 20 years, but then they just keep changing it as things change. The most recent time they probably changed it was when they updated it for variable speed. If you look at any Carrier or Bryant manual, it'll always tell you down at the very bottom. This one was updated in 2018. So that is the most current one that is available. But you may have older ones, and it's probably got a lot of similar stuff like David mentioned on there. What specifically you want to go to on here next first?
Generally, if you just scroll down on it, it's going to list everything. Obviously you could reference in the index what it's going to be, but it's also going to give sizes as far as if you'll look on here. We have, liquid line size, and they're showing 1/4 inch, 5/16, 3/8. So depending on the units we're talking about, and that's been different for a while now. Carrier used to be a solid 3/8 on everything. And then at some point they finally, depending on the units, they came down with that liquid line size. Because of course, guys run into a lot of jobs where, again, there's lines that you can't change that are in walls, condos, apartments, whatever the case. And there is 1/4 inch line there, there's 5/16 line there. So they kind of loosened that up officially and started listing it as a possible option. Obviously, the 3/8 is ideal, but you can run those. So this is all, again, some of this information will be in the installation guides, depending on the unit. But then you always have the long line guide, which isn't just long line, it just gives you all your general information as far as what needs to be done or what is okay to do. And this is broken down. This says the inverter units. The previous version of this, which I don't think it's in this one, when I looked at it, was nice because it gave you the percentage of loss, which always came in handy for guys to take a look at. Can you scroll down?
Yeah.
Right?
I was just going to point out, we've been calling it the long line guide, and we always call it that, but that's like the secondary thing. As Dave pointed out, the regular piping information is all in here also. There's a little bit that's in install book, but as soon as you do anything special, this is the book you're in. And usually we're going there for long line reasons, but there could be other reasons why you're checking this book out.
Yeah, so
Like in this case, vertical unit, if it's higher than normal or below normal compared to the height of the indoor unit. Where do you want to scroll to?
I just wanted to scroll through this to see. I'm pretty sure they heard, and right here they're saying you're showing your losses as far as your footage. We're talking about, no different than PVC. When we're counting off, if you have a line set that has lots of fittings, obviously that is eating up footage in that line. So something that if you had something that was more extreme that you actually have to reference, yeah, you have the amount of footage that you would have to count up for your fittings. Again, no different than we see with the PVC fittings when we're trying to vent a furnace. So that stuff matters. Again, when you have, when you're at a point where you're kind of trying to squeeze every foot out of it you can, be as accurate as possible. This is all stuff that, again, you could very easily look up and then just add up, what you have in fittings. Most of the time, it really doesn't come into play, but there are those jobs where it can.
We did have a question come in from Alan. If a line set is put into a PVC channel and sealed and insulated on both interior and exterior ends so that it's not in contact with the soil, does that alter the 3-foot rule for burying of the line set?
No, it's still buried. If you're underground, that temperature is going to be different. It's a big problem. So yeah, unless it's somehow, open to the atmosphere and you're getting air into that, because you're always going to be, when you're below ground, you're always going to be at lower temperatures. So that does not necessarily wash. As far as being able to do it, the thing you would have to do at that point, if there's something that you can't adjust, is to have it, have a grate or something and, dig a trench and grate it, put a grate over it and run your lines that way. That would be the only way to kind of stay, even with the environment or equal with the environment that's around the actual condenser or heat pump itself.
So it sounds like sealing and insulated actually makes things worse in this scenario.
Yeah, it doesn't really help anything because, again, you're below ground. It's just, if you just look at everything as far as, our geothermal, you talk about geothermal equipment, the whole idea of burying underground. So, we can utilize that, 50-degree or whatever it is at, depending on, how far under the, topsoil we are, and getting that consistent temperature of, say, 50 degrees. And then we just temper that with, basically our heat pump inside, with that, tempering that water, either warm it up a little or cool it down a little, and boom, there's our temperature, because we have consistent cooler temperatures underground. And that's why we don't want our regular line set buried, because, again, pressures, temperatures are very important when we're talking about, a heat pump or an AC, trying to maintain pressures so we can remove heat or, well, dump heat depending on which side of the system we're on.
Anything further we need on the fittings page here?
No, we go down and again, I don't think we have anything as far as like we have in the old version of this with the percentage of loss. We should have had one of those ready because that's actually kind of nice to have.
There is a bunch of mention of pistons in different spot here, and obviously everything we have now is TXV.
Well, piston, that's the kind of people are not aware that piston sizing, for some reason, pistons aren't good enough to use on evaporator coils per our design engineers, because it's not efficient enough. But yet on our heat pumps, pistons are okay to use as a metering device.
On the
So
outdoor coil.
on the outdoor unit. So, and that would be, your TXV again is only taking care of your indoor coil as far as your AC goes, as your cooling goes. When we're talking about heat pump operation, we're going to have an EXV or a piston on that heat pump that's going to regulate the refrigerant for our heating calls. So we're going to see, stuff about pistons, the different size pistons, and that information will also be in the installation guide as far as the piston, actuator, whatever you want to call it for the heat pumps. So we're going to see more and more mentions of pistons coming around now because of the heat pump side of things. A lot of people don't realize it because we still don't have tons of familiarity with heat pumps. But, the majority of heat pumps have a simple piston regulating that refrigerant.
Most of you guys are doing heat pumps with us now are doing inverters. So those will have an EXV outside instead of a piston or a TXV. But if you're doing, single or two-stage units with us, then we have a piston out there. What else do we need to cover out here? Charging.
I think the rest will just hit in there. Charging. As far as the refrigerant charge adjustments, again, this is kind of the standard. On your line set, we're at 0.6 ounces, generally on that 3/8. When we got a 3/8, 3/4, whatever it is, that 0.6 is our general add for the systems, and everything kind of goes by that. That is adjusted, down depending on that liquid line size, a 5/16 or quarter. You see that drops off. That doesn't really come into play a whole lot, and I think even if it did, most people probably don't acknowledge it. So sadly, units are probably getting a bit overcharged when it comes to that.
The purpose of this is to get your charge close, and then you'd still check your subcooling anyway to add or subtract from there.
You should always confirm once you charge, whether using a charging set up on an Infinity or Evolution system that, our weigh-in charge option through that controller. That's going to tell us what we need. We should always go back and confirm our subcooling. Not knowing that you might have a unit that came short on charge, possibly, could always come up, and that obviously will affect operations. So you should always confirm after charging with your subcooling.
So they actually give us a couple examples on here. And if you look at them, the first example on here is 15-foot of line set with an existing 1/4-inch liquid line. What adjustment do you need to make? So on the chart up top, they're showing you it's 0.27 ounces per foot if you have a 1/4 inch. So you multiply that by the 15-foot line set. And then the unit came, in this particular case, factory charge came, an example, with a line set ready for 9 ounces of refrigerant. So you take that back out, and that leaves you with having 5 ounces too much. So you get 5 ounces over in that case. The other example, they're giving you 45 feet, a 5/16, same kind of thing. You look at the chart, 0.4 times 45 feet, take out the 9 that was representing the current line set that it was defaulted to. In this case, 9 ounces is your difference. You got to add that in. And then obviously do your subcooling check after. So this book is sort of generic. Like Dave mentioned, some models like the 5-stage unit have a maximum of 100 feet. In general, 200 or 250 feet is more common. This one's saying maximum actual 200, maximum equivalent 250. So they're giving you 50 feet in that argument for any elbows, fittings, etc. that have a penalty, as Dave mentioned earlier. I think all of our units have a hard shut off TXV, right? So we're good
Yeah.
there. If you're using somebody else's coil, then some of this math becomes a little, or some of this thought becomes a little bit different.
Which you should never do, because those coils are probably no good.
Yeah, only buy our coils. Hard start kit and crankcase heater. So on any of these long line applications, we're doing both of those.
Yes.
If you have an inverter, that's basically built in. You already have a soft starting situation there. So you don't have to add that part of it.
And a lot of the units, again, depending on the unit you're purchasing, you may have the crankcase heater ready. I'm not sure what comes with hard start kits, but again, some of this stuff varies depending on the equipment you're talking about. Obviously, the lower end, less expensive units, however you want to put it, those aren't going to come necessarily with any bells and whistles or extras.
And what's the reason for sloping the vapor line towards the indoor unit?
It's just they kind of insist on that, and I don't know how many guys really acknowledge that. The reason is, again, the exchange with oil and movement and everything. I don't know too many guys who've ever adhered to that. As far as the systems go, everyone just kind of runs the lines out. Generally, it's something that doesn't come into play because most of the time, most units are actually in basement of a house or at least at the same level, depending on what we're talking about, where we're running lines. So that doesn't even come into play. And then as far as trapping goes, since we're kind of on that, generally we don't see any traps in any of our systems.
For residential.
For residential. Yeah, some of this could change, obviously, commercially, or if you get into, say, a Flex unit that we sell quite a few of, that could change depending on the line set on that.
We mentioned before 200 foot was the maximum length as a generic answer, but the model and size does make a difference. So as you're seeing on the chart here, you have some different rules on here depending on what you're looking at. Maximum total equivalent length without doing it below the indoor unit. So you have some different rules on here for when you go vertically, changing your maximum. Accessories required, pretty much TXV. As soon as anything happens, TXV. What else do we need to cover right now?
That's probably about it on that. If we could, is it possible to get that old line set up or old long line guide? Can I get that over to you somehow
If you have it, yeah, send it to me.
I should have that just so.
Well, Dave's sending me another older version of this book for us to look at. If you guys have questions, type them in. Also, we're deciding what topic to do next month with you guys. So it'd be nice to have some feedback from you guys since you guys are the ones logging in quite regularly on what you might want to see on future months, on what topics are of interest to you, specifically things that are service orientated and generally residential or like commercial would be okay if you got, small rooftop type stuff or something like that. Not really the audience for chillers, but let us know what topics you want to see in the future and we'll get those on the list here too.
How do I get you off my screen?
While Dave's doing that, I'm gonna pull up a video for you guys that we were talking about and Dave thought would be beneficial. It's a short video, like 3 minutes. We're gonna play for you, but it's a brazing video in regards to flowing nitrogen. And there's this NitroView accessory that quite a few people have been using and seem to like. So we want to show it to you to make sure you are aware of it as well. So hopefully this plays through the feed pretty good here. Sorry about that. I was showing you a screen of nothingness, apparently. So I'll watch the video twice.
The NitroView easily connects in line with any nitrogen regulator and was designed to be protected from impact in case the tank tips over. The precision adjustable valve gives complete control over the flow of nitrogen, and the bright orange flow ball provides a visual indication that nitrogen is actually flowing. The easy-to-read flow indicator label has two zones clearly marked for purging and brazing, and there's a safety blow-off valve that will open at 200 psi to prevent overpressurizing. Now I'm going to show you how to braze a copper fitting together with nitrogen flowing through the line to prevent oxidation and the resulting scale. So I have two pieces of copper tubing set up here. My top tube is open at both ends and exposed to the ambient air, and the bottom tube at one end is open. The other end is closed with an access fitting brazed into it. And attached to that access fitting I have the nitrogen tank. So we're going to braze two pairs of copper fittings together, one on the top tube and one on the bottom tube with the nitrogen flowing through it, and we'll take a look at the difference. First, I'll dial in the delivery pressure on the regulator to 60 psi. This is the required pressure for the NitroView to work properly. Then I will open the valve and raise the ball up to the purge zone and allow the air present in the tubing to be pushed out. Now, if your flow ball does not rise, this means that there's static pressure and the nitrogen isn't able to flow. So you have to make sure that your system is open at both access points so the nitrogen can flow freely. After 10 to 15 seconds of purging, I can bring the flow ball back down to the braze zone. Now in this zone, the nitrogen will be flowing at 3 to 5 SCFH. It's important to have this low flow of nitrogen because if there's too much flow, the nitrogen will actually push back on your joint. It's going to cause pinholes in your alloy. It's not going to give you a very good seal on your joint. So it's important to have your NitroView set in the braze zone to give you that low flow of nitrogen. Now let's go ahead and braze these joints. Safety first. By flowing the nitrogen through the tubing during brazing, oxidation will be prevented. Oxidation is the chemical reaction that occurs between copper and oxygen when heat is applied. Now this chemical reaction forms a layer of black flaky scale on the tubing called copper oxide. So all the scale that you see on the outside of the tubing after brazing the joint is actually also happening on the inside. And it's important to prevent the scale buildup inside the tubing because when it combines with the refrigerant, it will form a sludge that can clog the TXV valve and other components, leading to system failure. By flowing nitrogen through the line during the brazing process, the oxygen is displaced inside the tubing and the copper oxide will not form. I'm just going to cool these two joints with a wet rag and wipe off the scale that formed on the outside of the tubing so that when I do the tap test, we will only see what falls out of the inside of the fittings. Now, as I tap the fittings on this white table, you can see the black scale falling out of the joint brazed without the nitrogen. The joint that was brazed with nitrogen flowing through it has no scale to fall out and is perfectly clean on the inside. I'll just cut these joints open to get a better look on the inside. Uniweld's NV1 NitroView is truly nitrogen purging simplified. Thanks for watching. I'm Matt with Uniweld, quality tools that go to work with you.
All right, so hopefully that was helpful. If anybody has any questions about that, we're happy to take them.
And thank you to Matt from Uniweld. Did a great job.
We will hire him for TEC too.
We do not sell that Uniweld NitroView, just to be clear. It's a good video, nice tool. A lot of the new regulators you can purchase go down in those very low pressures, and you're able to, simply purge with them now. Where on the older, if you have an old style regulator, you can't really go that low. So in that case, you'd need something like that NitroView or some other type of tool, from another company that would make you able to control that flow a lot simpler, waste a lot less nitrogen too, trying to get that set right. So ideally, when you are brazing those lines, you have a tool like that on there just to make your life easier. You don't waste nitrogen and you're keeping all those lines as clean as possible as you're brazing, so you don't run into problems later. Clogged TXVs, pistons, EXVs, reversing valves. We could go, down the list of things that are affected by poor installation practices and running the lines. So you want to make sure you follow all these things as far as purging goes. During the braze, checking for leaks, everything that should be done on an install. All the stuff that kind of we've been, really should have done all along, now coming in with the new refrigerant coming, down the road very quickly. Now all these things are required more, instead of just being suggested.
The item on your screen is the quote unquote old piping and long line guide. This one is from 2009, so pre-inverter as far as carrier residential inverters will go. So Dave brought that up for us, so we can go look at, I forgot what table we're gonna go.
We're gonna look at the loss, capacity loss, so you just go comes up pretty quick.
There we go.
There we go. So they list, this was nice about this one. If people were concerned as far as your loss, if you look at that, very first one, we have a 1.5 ton unit, single stage. Our liquid line is 3/8. And then our suction line, it's listed as 1/2, 5/8, 3/4. And depending on what that size is, and that distance, 26 to 50 feet, it gives you your percentage of capacity of loss. So let's say we have that 1.5 ton unit, 26 to 50 feet, and we have a 1/2 inch suction line. We're gonna have 1% loss on that. We go to 51 to 80 feet, we're up to 2%, and down the row. So 3%, 5%, 6%. So this is kind of nice. It gives you an idea, as far as the line sizing, that we do have flexibility generally with units and the possibility of loss depending on lines that we're unable to change because we can't get to them. So it pretty much breaks it down well, and that's a good thing for guys, because over the years, I know in tech support, we've had to send us out, or we look up for guys because they tell us, what they have. They're not aware that this is out there. And, so they're just wondering, hey, I can't change these lines. Am I able to do this? And, how's it going to affect the system? So real easy to point out the capacity of loss. And in a lot of cases, the loss isn't really that much. I mean, is it going to matter that much if you're 2-3%, 5% even? That's not a whole lot to talk about, especially considering so much stuff is oversized to begin with. So
What? I've not heard about that.
we
Is that new?
it may
Oversized?
improve your operation indirectly. But that was always a good thing, and something that was referenced, quite a few times over the years for guys to understand that, or you just send them, you snip the chart and send it to them so they could see. So like I said, again, we have a decent amount of flexibility with most of the units. I mean, even looking at this, we go a 5 ton with 3/4 lines. I mean, you could go up to 100 feet with only 4% loss, on a single stage unit. It's not very much at all, considering, it's a huge difference when a lot of people automatically, they see 5 ton and they think if it's over 10 feet, you got to go 1.125. So units are capable to work pretty well with different size lines, sometimes surprisingly well, depending on what we're talking about. But again, variables with everything, you can look this stuff up and confirm just so you know where you're at with these things. Also with the getting back after our brazing, our vacuum pump, we want to evacuate the system, get that system as clean and dry as possible. Nowadays, they're recommending, with the going into the new units, the 454 units, the triple evacuation, where you're just basically, you got your vacuum pump on, nitrogen, a nitrogen purge, then it's a purge, depending on what we're talking about, blowing nitrogen through the lines, pressurize and blowing it through, and then your vacuum pump again, and you're doing that 3 times. Basically to get those lines as clean and dry as possible. which is the best way to evacuate. But we know that in a lot of cases, guys are just kind of going with the old school, hook up the pump, blow out the lines, check for leaks, do all that, hook up your pump and get it down to 500 microns or better and make sure we're good that way. So, that's kind of, I guess, our old school way, but the new way we're supposed to be doing is a triple evacuation, which is exactly what it's called. We're running through that process 3 times.
What other questions anybody want to send in to us? Or anybody want to recommend topics for future months to be addressed? But I like the level of response. All right,
Maybe just open up the mics and just let everyone talk the whole time when we do this.
probably outside staring at the sun right now.
Then, are we missing the eclipse?
We got a little bit of time. Looks like someone did send us a question. Between Steve May's questions typing in and Neil's texts, everyone's picking on us, man. Apparently, no one likes our haircut. Steve Mays is not impressed with Dave and mine hair. 2:07 p.m. Pete says is the eclipse.
Steve is a negative person, so we're not going to even acknowledge what he says or types. Thanks for letting us know about the eclipse. I was concerned.
All right. Well, if there's no other questions anybody has, if you do come up with topics later, let us know. Alan just said he's going to pull some of the people in his office and decide what they want to hear about. These are flexible, so each month we're doing whatever things people seem to ask about most. And so far we've got a couple of them knocked out, and we're ready for the next couple. So, thank you guys for your time, and we'll chat with you in the future.
Okay, thanks, guys.